Hello. Welcome back to my journey of hacking RPA. In this video, I'll give you a brand new zero-day method of hacking into real-world RPA deployments. Just follow me step by step. I'm expecting two types of people to watch this video. First are those who have an information security or cyber security background and have basic understanding of RPA, but do not have an year or two hands-on. And second are those who are dedicated to automation and have general understanding of security but are not core pen testers. Since there is a minimal overlap between these two groups, I will explain everything in detail, which will make the video long, but I'm hoping that's okay. Before I move on to the next slide, I'm hopeful that you have already seen the first video of this series. If not, pause this video here, go to my channel and watch the first video of this series, Hacking RPA 1A. We will use points and concepts which have already been discussed in that video now. To ensure that you understand everything that I am talking about, do watch it first. Before we start, take a minute to read through this. I'm going to assume that you paused the video and read through this. So I'm going to move on to the next slide. Let me quickly recap. In the last video, we discussed how to exploit local components of a UiPath for fun and profit. We saw what is the shared location on which packages are shared by default, and if one gets access to that, how he can explore the package for confidential information like credentials or private areas of a confidential application, which the RPA bot is trying to automate. We also saw how an attacker can go a step further and backdoor the package files so as when they get executed or distributed, the attacker can run his malicious code on the RPA machine to take over the machine. However, exploiting local components is not enough. Actually, when I asked a friend who is a UiPath expert, his feedback on my last video, he was quite dismissive about it. He said that that's not how deployments happen in actual world. In actual world, all deployments happen through an orchestrator. Packets are not saved locally, so you won't be able to modify them. Moreover, orchestrator also stores all your confidential information like credentials with it, so you won't be able to steal the so-called juicy information either. Keeping that in mind, in this video, let's see how deployments happen in a real world and if we will be able to hack into them. Let's start with understanding what is the orchestrator. As per their introduction page, which is here, let's quickly go there. There are 4 types of robot use cases that it can help you with: attended, unattended, studio, and non-production. And its main capabilities are provisioning, deployment, configuration, triggers, and queues, and few other things. You can more about them in the documentation. So to summarize, it is a one-stop shop for all your RPA deployments. You have this and UiPath installed on a machine, and you should be able to do whatever you want in RPA. It can be installed on-premise on an IaaS, or you can use their cloud service. We'll be using their cloud service as the others cost money, I think. We will talk about how the orchestrator works in much more detail, but before that, let me show you the setup that we'll be working with. So there is a firm called Private Finances, which is enthusiastic about new tech and uses RPA. UiPath to be more specific. RPA is used for 2 projects here. First is the automation of a financial application. It would be something like an ERP, maybe a SAP application. And second deployment is for automation of printer activities. Maybe they have an old printer and few repeated activities need to be performed every time a printer job is given. So they have a bot for that. The printer bot is deployed on a public computer in the reception, which is accessible to anyone in the firm. In fact, even visitors, if they need to do a printout, can use this machine for a minute or two. In the real world, you will have many more machines doing many more automation activities in many more networks within the same enterprise. So as an attacker, what is my goal here? As an attacker, my goal is to get access to a machine that is running the financial automation and thus steal money from the firm. But before we jump into hacking into the company, let's see how the orchestrator actually works. Let me parallelly open the orchestrator. You can skip next few minutes if you already know how it works. Okay, so this is the login page. I'm going to use login with feature. If you are like me, you should be thinking login page, the first way to attack should be phishing. I'm not going to phish the page in this video. I used to do phishing when I was 15 years old. I'm around 30 now. And in an enterprise environment, you should have this using SSO. So phishing is not a worthy attack vector here. Let's log in. Here in the orchestrator, I'll take you through the important sections step by step. So first thing that you need to do is go to services. I've already selected services, and this is the service that I'm going to use. Within services, the first thing that we do is define a machine. It has to be a replica of an actual machine. So already I have multiple machines defined. These are a few machines that have been defined for this video. Let me quickly show you what does the finance machine 1 looks like. So you can't do much if you are trying to define a new machine. Instead of this, if I just, okay. While defining a machine, you have 2 options, standard machine and machine template. I'm not going to discuss machine template, that is out of scope of this video, but let's go with a standard machine. In standard machine, there is not much to define. You just need to give the name and description, and you should be good to go. Once the machine has been defined, UiPath assigns it something called a machine key. And you can see the machine key here. Okay, so the next step is to create a robot you want to deploy on that machine. So let's go to robots. This is the finance robot that has been defined for this machine. And while you are defining the new robot, again you get 2 options. One is standard and second is floating robot. We'll not discuss floating robots in this video. Maybe an enterprise video would be a better fit for that. Let me try to define a standard robot. So it is saying on which machine do you want to deploy this robot, that you need to select. Then you need to give it the name, and then what kind of robot do you want it to be. Do you want it to be studio, attended, or non-production? Then you need to give it the authentication details of the machine on which the robot will be deployed, including the domain and the username, and a few other details like the description and others. I've already defined multiple bots for the users of this video. This is what my finance bot 1 looks like. Moving on to the third step, you need to define environment. So let's say that you have 3 bots doing similar kind of functions, like finance bot 1, 2, and 3 deployed on machines, finance machine 1, 2, and 3. So you can add all of them to a same environment. Here are 2 environments that I have defined: finance and printer. Finance environment has 3 machines on it, and printer has just 1. Let me go back just to, so here is the name of the environment that you can see. Okay, so Right after you have defined the robot and the environment, you would basically want to write the code for deployment. So you would install UiPath on a machine, then run the robot, and then change orchestrated settings in UI Studio. Develop and publish the package that you want to run. We will show you that during a detailed orchestrated demo. Or maybe we'll just skip these steps because they have already been done for this environment. Next thing that you want to do is define a process. So I'll go to processes, and this is what process looks like. Basically, the packages that you have already published using a development machine are available here, and then you can select one of them, and okay, so let's select that, and then basically you can define which package version on which environment you want to deploy it, and few other things. I've already defined two processes here. One is finance application, second is printer automation. The fifth step is how basically you would want to add a trigger. How frequently do you want to run the bot? So I have defined another trigger here for finance bot to auto start. Basically every 10 minutes the finance application automation runs. Let me enable that. Okay, so now it has been enabled. It will try to run every 10 minutes now. There are a few other details in the orchestrator, assets and packages. Basically, assets are confidential information. Let's say that you have FTP credentials to be accessed by a specific bot or by all the bots globally. So here I have defined one FTP credential global already, but if you need to define something new, you can define that. These are the types of definitions available to store in the asset storage. Okay. So now that we understand how it all works, let's discuss the attack. I will run through the slides and jump on to the demo. Okay, so for the demo, let me show you the setup that I have created. So these are the three machines that we'll be working with. Finance machine 1, lower budget project, that is the printer automation, and third is the attacker home PC. So this is what the lower budget automation machine looks like, and attacker PC will come to in a second. If we go back to the orchestrator, we can see that it says finance bot 1 and printer bot 1 are now connected, and they are respectively running on finance machine 1 and printer auto 1. And if we look at the triggers once more, it basically says that finance bot will again run in 6 minutes. That's fine. So remember, we said that the visitor will have access to this printer machine for just a minute or two. What can he do in this 1 minute? So basically he can go to the tray, he can look at UiPath robot, he can right click, go to orchestrator settings and copy these three informations. In case he doesn't have physical access, in a pen testing exercise you have just got access to this machine using a CMD shell, then in such a scenario you can go to C drive, username, and app data, roaming, UiPath, and UI agent settings. You can open this with Notepad, and here is the values that you are looking for. UiPath says that this machine key is encrypted. However, pass the hash attack kind of works perfectly. You can just copy this value and paste it in the attacker machine, encrypted itself, no need to decrypt it. So I mean, this encryption is not really a problem. All right, so let's do that. Let's copy these settings. And these three things I have already copied in this node file: the machine ID, the URL, and the machine name. Let's go to the attacker PC and let's see what can we do. So let me launch the UI robot. But before that, basically this attack to work, this printer machine needs to be not connected to the orchestrator. So there can be few scenarios. There can be a maintenance window. The receptionist could go home. She could just shut down the PC, or the attacker could get creative. He could perhaps just switch off the power or do other things. So I'm not going to demonstrate how he's going to shut this machine down. For this particular demo, I am just going to take this machine out so I can perhaps do a power off just here. And once the machine has been power off, if we go to the robots here, this one, when this thing refreshes, it should say that this particular bot is no longer connected. And okay, so orchestrator will realize perhaps in a minute or two. We'll come back to that, but let's start with our malicious intent. The attacker goes home, he powers on his PC and then tries to configure these three values. So let's do that. So I have launch the UI robot and it's sitting in the tray. Let's go to but we have a problem. The machine name here says it's home PC, and the machine value that we actually want is printer auto 1. How do we do that? Basically, this is attacker's home PC. He can do whatever he wants. He can just go to the machine name and change it. So let's do that. And the value that we want is printer auto 1. So okay, the machine will ask me to restart. Which is fine. We will restart this attacker PC and let's see whether printer bot has been realized to be offline or not. It still says that printer bot is online, which is okay. When I try. Even though we have shut that machine down, since there was no logout handshake, I think that's why it is not recognizing that printer bot is no longer online, but doesn't matter. Okay, so now will we be able to impersonate the printer machine? Let's check that. Okay, so it has now realized that printer machine is no longer online. It says unresponsive. That's fine. Let's go to the orchestrator settings, and this is the URL, and this is the machine key that was available in plain text. And let's try to connect. Okay, so it says connected and license, and this printer bot in orchestrated thinks that the printer bot is back online. So we have been able to successfully impersonate the printer machine to the orchestrator. What more can we do? Can we do anything malicious? So let's see what was the job that was configured to be launched. So printer automation is the job that basically this bot would have launched if we would have run it. So where is this printer bot automation stored? it is basically stored in C drive users username in .NUGET. Here are the packages that you are looking for. If you see, printer automation has been created today. So that's fine. Let's copy this this package file and let's see if we can do anything malicious with it. I am not going to copy this folder, it's useless. Copy and let's go to document and paste it in this folder, printer. Okay, fine. So let me launch UI Studio. While it is launching, let's reiterate the steps. Okay, so finance bot is expecting execution at the moment. Let's see what's happening with finance bot. So this is the application that would be running. In real life scenarios, you will have a much more complicated step, but here I have just given a pop-up window for this project. I hope that demonstrates it adequately. So let's do open project. So far what we have done, let's retrace our steps. So far we have impersonated this step we have completed, and we have completed this step as well. He accesses the available package. This also we have completed. Now the next step would be he opens the project in Studio, backdoors it, and publishes it to Orchestrator, and wait till the admin updates the process. Okay. So we have successfully opened the package file. Let's see if we are able to publish this file. Okay, but before we publish, let me see if I can do any changes or not, but because without changes it's basically pointless. So let me just add something. Let me add a message box. Okay, so I made one change. Let me try to publish it, and it is currently publishing to Orchestrator. The new version I want it to be is maybe 1.7 is fine. So it says that it has been published successfully, version 1.0.7, and let me see if this package is appearing in the Orchestrator or not. Let's go to packages. Here are the printer automation packages, and 1.7 has just been published a few seconds ago. So next time when the administrator opens printer automation, he will see that there is an update. He can just go to view process and update it to latest, and this version will now be executed in the printer machine. But that's not much of an interest to me, because that machine is a public machine and it does not have any confidential information. What I want to do is I want to get into this environment, highly confidential finance application, and then perhaps transfer money and get rich. So how do we do that? To demonstrate that, I have made a few changes in the setup. I just paused the video, and then what I did was I launched this Kali machine, and in this attacker PC I launched an instance of Burp. Burp is a tool which is used to intercept traffic. I did the same thing that we did before. I launched UI robot, and then I published the same package that we found in a NuGet packages. And let's see what happens in Burp. Basically in Burp, first authentication happen, then session begins, then it does a get processes. And what is the response for get processes? You get a list of processes, and then services started, then it does a metadata, and it looks for assets. Assets are basically credentials. Okay, so since now this traffic has been intercepted, I am going to use this traffic to see if I am able to get more information or not. Basically, if you see here for releases, sorry, that's not the order in which this communication happened, but yeah, basically if you see in this releases, if the bot tries to do a query to what are the releases that have been done, the response is you are not authorized to see what are the releases. Releases are basically versions of a package, but there are other things that the bot is is able to do. So let's send this request to repeater, and what if I want to look at all the machines that are available. Let's send this request and let's see what is the response, and we get a list of all the machines that are available. Finance machine 1, and then we have highly confidential this, and what is the bot version, and then finance machine 2 and finance machine 3, and of course printer automation 1 as well. Can we also do a query to what are the packages available? So for that, I think the command is and yes, we get a list of all the packages available as well. So there is a package called finance application, which is of version 1.0.8, which is running on, of course, finance machine. It should be running on finance machine 1. So can we do can we use this information maliciously? Of course we can. So let's open another project. I'll go ahead and open the older malicious project that we created in video 1. And in this project, if you remember, the project did not do much. It just connected to my Kali machine, downloaded a malicious script, and then ran that script. So if now we try to publish this package, will it go through? Okay, and before we publish it, I want to basically change the package name. And I want to change it to this value, finance application. Okay. And the version that was published was 1.0.8. So if I try to publish it with version 1.0.8, will that go? Not really. It says that that package already exists, which is fine. I mean, if the package, if we got this error message, means we are on the right path. Let me try to publish this with a newer package version. So instead of 1.8, I'm going to publish it to 2.0.8. 2.0.8, and let's publish it now. Okay, so the package has been published successfully. Now, when the orchestrator admin sees his list of processes, he sees that in finance application there is an update available. So he goes to view the versions, and then he says that a new version 2.0.8 has come. So he will not do that. He will not come to this page immediately. Once there has been some modification to the process, then only he'll come. And let's say that there has been another update. So after 1.0.1, let's say a version 1.0.9 has been published. Irrespective of what is the next version which was intended by the developer, if he clicks on this button that is latest, then the highest value here will be selected, which is 2.0.8, which is our malicious package. And let's see what is the time that will be taken by this trigger. Basically, this trigger says that in a few seconds this malicious package will now be executed. That's great. So let's go to this finance machine, and this package has been run. Did we get anything on Kali? Okay, so we got a call from some machine, not sure which one, but anyway, let's see if we got the right machine. And voila, we are in the finance machine. Can we do a sysinfo? And we can do queries, and now that we have a shell, we can even run metasploits and do other similar malicious activities. So we have now successfully intruded into our target. Let me do one more command, which is ifconfig, just to demonstrate that we are on the right machine. The machine is 132.138, and what was the IP of our finance machine? It is 132.138, so we are on the right machine. All right, so we can do malicious activities here. All right, so I think the demo has been successful, and we have successfully demonstrated that the attacker can potentially intrude into this machine, this network, and then steal confidential information and maybe even transfer money and get rich. Okay, so now that we have discussed the attack methods, let's talk about how an enterprise can defend itself. What can you do as a customer or a user to protect yourself? Basically, you need to ensure that the orchestrator URL is not accessible to the open internet, even through the API. So if the orchestrator URL that we used was platform.uipath.com and then our private space. This URL will be public because this is a SaaS offering, but if you have deployed the orchestrator on-premise or IaaS installations, then you can restrict it to your specific private networks. The next thing that you can do is get separate services for separate networks and environments. For example, here we had created so here we are in the services folder, right? Here we have everything under the same services folder, that is private finances. Instead of this, what we should have done is we should have created a service for finance application and another service for printer automations. Then this URL would have changed, and basically you would not have a option to cross publish packages. You'll have to spend more money, but that is better than getting your network compromised. Third would be orchestrator admin needs to pay special attention while updating the packages. He needs to talk to the developer and confirm on the version number. If possible, go to the process explorer and verify that the package does what it is supposed to. He can also ask the developer to sign the packages and ensure that unsigned packages are never activated. All right, so these are the few things that as a user you can do. And all these attack vectors would not have been possible if UiPath software and design did not have some flaws. So let me take the final few minutes to offer some advice to the UiPath as a firm. Having a development environment on every production and testing machine is a bad idea. It would be great if we could have separate installations for studios and robots. Testing and prod robots should not be allowed to publish packages. And if we already have such a deployment model under some license, which I do not know about, apologies for that. The second point is encryption of in the file C users app data roaming path UI agent settings is vulnerable to pass the hash attack. So maybe you guys can work on that. The third point is robots are allowed to get information on other machines and processes as shown in the video using Burp. So it would be great if you could work on that. Robots should not be allowed to publish packages to other environments. That is another area of improvement. And if we could have encryption options in a package, that would have been nice. These attack vectors could be minimized further. Okay, so I think I'll be making a third video in the UiPath series in which I'll talk about enterprise components like AD authentication, machine template, floating robots, maybe over a VD or a Citrix. I think in that video I can have copyright or licensing issues, so that video will be private. If you want me to take a session or maybe watch that video, drop me a note. For the rest of the internet, I hope this video has been informative for you, and I'll see you in the exploit for next RPA platform.